My name is AJ O'Neill. I am a longtime JavaScripter. If you ever joined the JavaScript mailing list for Utah, I'm the one that started that. I don't think anybody uses mailing lists anymore, but they were great back in their day. I've come here to incite, hopefully, nothing, because you're all programmers and you understand some amount of logic and whatnot. But if not, I'm here to start a holy war. Okay? Decentralization might be the right God, but blockchain is the wrong religion. So we're going to start off with a very simple question. Do I need a blockchain for that? No. All right, my work here is done.
What is a blockchain?
Oh man, that is such a good question. All right, should we get into that now or later?
Now.
All right. Yeah, so that I don't know, if we talk about that already, that might just shortcut the whole presentation. Let's sidestep that a little bit. Let's say, why would you think you would need a blockchain? Does anybody have any ideas? Like, you hear all this stuff floating around. Why do you think you would need one? For marketing purposes. I think that might be the only correct answer, and it's still wrong. No, so I founded Daply, and since then it's a home server, and well, now it's a blockchain app thing. I'm not part of the company anymore, and I'm starting this new thing, which is called People. And people.family is where the site is if you're interested about that. I'll talk more about it later maybe. But and then so in this space of home servers, like, these other things are popping up, and one's called Holo. And so they actually put blockchain in their marketing, but then when you read, like the rest of the paragraph, it's like basically saying, we don't use a blockchain at all. We just do efficient stuff and accomplish goals, and we just put the word blockchain in there so that we get some SEO. Which I thought was, I don't know, it kind of has a double effect of, yeah, they get some SEO, but then people like me are skeptical. Anyway, marketing, anything else? Yes?
Medical records.
Medical records. So, I have no idea, but we'll put that down there. So, in particular, like, what kind of problem do you think it would solve? Yes?
I was going to say security.
Okay, security. Okay, what else? Redundancy. That is actually maybe the only problem I ever heard anyone mention that it does. I don't know that it does it in a way that would solve a problem. And I don't know if I spelled it right. Anything else?
Trust.
Trust. Oh, another one that it doesn't solve it. Oh.
Escape from Wall Street.
What's that?
Escape from Wall Street.
Escape from Wall Street?
Yeah.
I'm pretty sure that all that's happening in Wall Street right now is the blockchain, but we'll put that there.
I mean, they say it's financial freedom. Yeah, sticking it to the man.
There we go.
Play the power.
Man. This is great. Anything? We got one more.
It takes the power away from one central party.
Ooh, another thing it doesn't do.
There are countries that do money or water, that's a black money. They can do that with it.
Yes. So if you want to get drug money.
Yeah, drug money.
Drug money. It doesn't work for that either anymore.
If I sold electricity, I would encourage people to mine Bitcoin.
Yes. This chart does not represent electricity or represent Bitcoin prices. It represents power company profits. Good old coal is more valuable than ever. Okay, I'll stop with that. So I will get back around to what a blockchain is eventually, but basically I'm here to dispel some misconceptions. You're not going to see any JavaScript tonight. Hopefully that's okay. If not, leave. So a lot of these things that you said are things that are up here. Like these are reasons that people believe that they need a blockchain. They think they need a blockchain because really a lot of these are religious or moral arguments. Like decentralization is rarely used as an efficiency argument, although it can be extremely efficient. But when people bring up these conversations, rarely are they talking about like a technical benefit to a system. It comes across as more of like a moralistically, we live in a society where right now decentralization is kind of an object of worship. And then you got distributed. Again, this can be a very efficient technology. Peer-to-peer, there's a lot of stuff that's ideal about that. Trust, anonymity, privacy. None of these things are solved in any way, shape, or form by any blockchain technology that I've ever heard of, but they're things that people think about. So I'm going to go through those kind of one by one and talk in part like why this is a good solution, what use cases are, give examples of things in the real world that relate to these topics. And then at the end, we can circle back around to see if a blockchain helps that at all. So distributed. Distributed is usually two types of things. So I have here compute is one type of distribution. Have you guys ever, was anybody alive in Windows 95 era that like used Windows 95? Okay, so did you install SETI on your computer? Anybody install SETI? It is a program that is about as useful as the blockchain. It takes radio signals that have only come from like a couple thousand light years away, which is like well within the known universe that we can use telescopes, and tries to decode the signals as if they were from planets that were hundreds of millions and billions of light years away, where there actually could be intelligent life. That's something that actually takes segments of data and runs an algorithm on it and farms it out to many different computers. In some cases, a batch of computers will be working on the same thing, and it's looking for patterns, and then it's returning results. Something that's maybe not any more useful, but is certainly more practical is Prime 95. Anybody use that to heat their room in the winter? Prime 95 is another application, much like the blockchain, that runs up your electricity bill as high as it possibly can in search of Mersenne primes. So when Prime 95 is no longer of any use, we will have discovered every private key component in the RSA 2048-bit space. But then there's actually something that is kind of useful, folding at home. Has anybody heard of that? Okay, so this does protein folding. I'm not really clear on what that means, but again, it's taking groups of data, sending it out to a multitude of computers in batches, and then those computers are basically doing random things to try to discover a cure for cancer. And the idea is that basically it's almost like playing Tetris with proteins or something, and if it finds them in a way that they fit a certain way, then we've got a cure for cancer. So if we just get every computer running, if we had dedicated the amount of electricity to folding at home that we've dedicated to the blockchain, no more cancer.
So folding at home coin?
Yeah, that one coin would be worth a lot. Or I guess there could be different coins for different types of cancer. But it's something like that. And then you have mining networks. So the blockchain created a problem for which a distributed solution was actually really effective. So with the blockchain, like Bitcoin and all that, is basically a math game. You're taking hashes of a number, and then you're trying to guess another number. Somebody randomly generates a hash, and you have to find, if the hash is AEF26A and ... and the complexity is this, then you have to keep on taking numbers until you find a number that begins with this hash, is essentially what it's doing. And because that's that it now would take a single computer like mine something like 100,000 years in order to mine a Bitcoin at the current complexity. Instead, it goes out to 100,000 mining groups, or 100,000 computers in a mining group. Well, more than that, because that would still take a full year. Like 1 million computers in a mining group. And then just they all get a segment of numbers to guess. So it's like you're going to guess numbers 0 through 1 trillion. You're going to guess numbers 1 through 2 trillion. Where you're going to guess numbers 2 through 3 trillion, and so on and so forth for every single computer in the network. And so by distributing the guesses, some computer comes up with a number that matches, and then it reports back to its master node in its group, and then it solves the challenge, and then once the challenge is solved, then a token is awarded, and all other 400 million computers on the network in a very non-peer-to-peer fashion verify the result. So that is a problem that was created by a blockchain that needed a distributed compute solution. And then databases are often distributed. So compute and storage, these are the two types of distribution we often talk about in the computer space. So what this looks like is, Facebook as an authority is very centralized. You're either in Facebook's data or you're out of its data. But once you get into this circle that is Facebook, so there's 2 billion people on the planet that are all connecting to this central authority, right? That's Facebook. Inside of this central authority are lots of data node clusters. And these data node clusters are, in fact, distributed. So when, I'll talk about the Amazon example because it's a lot simpler than the social example. So in the Amazon example, there's so many Furbies this year that people are going to be able to buy at Christmas. Say there's 10 million Furbies, because you got to have a lot of Furbies. They're really popular. So there's 10 million Furbies, and all of the nodes in Amazon's data center network know that there's 10 million Furbies, but each node needs to be written to independently. So when I, over here in Utah, buy a Furby, that needs to go down by 1, so minus equals 1. And then when somebody in Vermont buys a Furby, it again needs to go down by 1. And so each node in the network is maybe responsible for a different set of data. So I'm connecting with this node here, and someone else is connecting with this node here, and maybe the node that's actually responsible for the Furby row in the database is over here. But these have a replica of the data, or they know how to get the data. Not each of them necessarily stores all of the data, and it's certainly not always up to date. But I make my purchase, somebody else makes their purchase, and when you get around to like 10 Furbies left, what you could do is say, oh, well, this is a really low number and there's a high purchase volume, we need to put a lock. So anytime somebody goes to buy a Furby from now on, we're going to wait for all the data to sync. But that would be a terrible experience, because then it would take like 5 minutes for you to order your Furby, and there's like 500 million people trying to order them because there's only 10 left. I guess it's not Furbies. What is it? It's Amiibo. That's what it is. It's your Nintendo Amiibo. That's what they're doing. And so in this distributed system, it actually allows for us to make writes to multiple different parties, and then they kind of resolve on their own, and then half the people get an email the next day that says, sorry, we're out of stock. Even though you completed the purchase and we told you that it was preparing for shipping, you're not actually getting a Furby or an Amiibo this year. So that when you have big data at scale, where you have to have different responsible parties, that's where distributed databases come into play. Hopefully that made sense. It made sense in my head, but it may not have come out in a way that made sense. Any questions on that? Okay. So, yeah, and the point of that is that everything has a different responsibility, a different role. Whether it's in compute or in the data, different computers or different clusters of computers are responsible for different things, and if a request is made to a computer that it is not responsible for, it goes and talks to the computer that is responsible for it, and if there is a conflict, it will figure out the conflict later on. Okay, so in the nature of the blockchain being a distributed technology, how many gigabytes can an SD card hold these days? You actually, 512 was just announced, but on Amazon, 256 is the largest. So if you get the largest SD card, but I mean, you can't even get this much in your phone. Your phone cannot hold the Bitcoin blockchain on it, like it can't. So this is a problem that really would be very well solved if there were a distributed solution. A distributed solution would mean that instead of there being a single blockchain that every single person has to redundantly replicate in order to participate at full capacity in the network, that like there'd be some nodes that are responsible for data segments A through C, and some nodes that would be responsible for data segments C through E, etc. So if the blockchain were distributed, we wouldn't have this problem of having to download 170 gigabytes of it. You'd only need to download some portion of whatever group that you were a part of. So yeah, it's not. Distributed is great, but it's something that the blockchain isn't. Any questions so far on that distributed section? Okay. Decentralized. What does it mean to be decentralized? So the best, most well-known decentralized protocol that I can think of is email. And the beautiful thing about email is that anybody can set up an email server. So I can set up an email server as only one person, and that email server will work. Gmail can set up an email server that is good for, 2 billion people. And Yahoo can set up an email server that's good for the 5 or 6 people that are using that. Are some of you in this room?
Right here. I still have, it's not a Yahoo email address, but it's run by Yahoo.
Okay.
I use it to give my credentials.
That's good. Yeah. And so the cool thing about decentralization is that each node can independently contact any other node through its node captain, so to speak. So I can be my own node captain like I am with O'Neill.im. This is one of well, I'm not, well, I am. Oh well, I'm recording this, but this is my private email address. Don't tell anyone. It's a secret to everybody. And then, I also have coolage86@gmail.com. And then I've got the same thing at Yahoo. But the point is,
These are all honeypots, right?
yeah, they are now. I can either create my own authority or I can subscribe to somebody else's authority and be part of their network. That's kind of one of the great things about something that's decentralized is that you can start one up on your own. So Jabber was this way, DNS is this way. DNS is different from the domain name system. DNS is a decentralized protocol. The domain name system itself has some politics involved, and anytime there's politics involved, there has to be some sort of regulatory body. So domains themselves do have a regulatory body. You can't, but you can own your own top TLD. So VeriSignOwns.com, you could buy. Somebody bought .ninja, you could buy .egghead if you wanted to. Like you can do that. So it is still decentralized to some effect. What else is decentralized? Banking. Now, the currency system is not so much decentralized. There's a single authority for that. But basically, anybody could start a bank. There's a lot of regulation involved. But that's kind of like protocols. Just like anybody can start their own email server, but you have to follow the protocol. Anybody can start their own bank, but you have to follow the protocol. The other thing, that the blockchain introduced this problem where anybody can fork a currency and create their own. And there's no way for them to communicate to each other because none of the blockchains are decentralized. So people created crypto exchanges that are decentralized that allow different blockchain networks to be able to communicate and pass money or tokens back and forth in the same way, almost, but not quite, that email, you can get an email from different email service providers. So in email, the protocol is actually decentralized. In cryptocurrencies, exchanges kind of overcome the barrier of it not being decentralized by creating their own type of decentralized-ish system. But it's more at the political level like a bank is than at the protocol level because there's not like an API you can use that is an independent API that would work with multiple exchanges. like with email. Everybody follows the same protocol. What Shapeshift uses and what Coinbase uses and all that, there's no common protocol between them. But politically, the concept of an exchange is decentralized. So there's the litmus test if you want to know if something's centralized or decentralized. Anytime you say the, you are speaking about something that is centralized. So there's the banking system describes, you're either describing a protocol or an entity. The banking system is a bunch of regulatory and wire transfer protocols. Email is a protocol. You could say the email system refers to the protocol. But when you say the blockchain, you're referring to the authority, the entity. So just a quick, anytime you're saying you have to figure out are you talking about a protocol? Because if it's a protocol, it might be decentralized, or an authority. Because if you're talking about an authority, it's not decentralized. Okay, peer-to-peer. Another thing that the blockchain fails at horribly. What's peer-to-peer? The web's pretty peer-to-peer. Like I was talking about before with the email server, like I can start up a web server in my house. You can start up a web server in your house. You can start one up on DigitalOcean. And although, there is some non-peer-to-peerness in that it has to go through the ISP, it has to go through a couple of routers, but the communication itself, the addressing scheme is a best effort in terms of the fewest peers possible. But the addressing scheme of the web, I type something into my browser, my computer makes a private connection to that other computer, and I'm there. Email, Skype sometimes functions this way in the optimal case, like Xbox Live, things like that. They try to establish a peer-to-peer connection, which peer-to-peer in this sense means best effort to fewest routes. Because anytime you're talking about a network, you have to go through something or someone else to touch base on the other side. Other things that peer-to-peer, cash money. Like I can walk over to you and hand you $5 and no one else has to be involved in that transaction. You could claim that it's not truly peer-to-peer because that cash money has a stamp on it from an authority that says that this money is valid, and so we both mutually trust that authority. So in fact, we are in some degree relying on a third party to validate the transaction for us. But money is like conceptually pretty peer-to-peer. And then bartering is like truth, peer-to-peer. I give you a banana, you give me a piece of toast. That was the peer-to-peerest transaction we ever had in our lives. All right. So the funny thing about peer-to-peer networks is it turns out that 400 million does not equal 2, which means that in a blockchain there is no attempt whatsoever to get the shortest path between two people. In fact, it is the longest possible path, because before I can exchange a token with you and be sure that that transaction is something we both agree upon, which it's not even a transaction because it's only one way, because a transaction would be giving something to get something. And on most blockchains, Ethereum smart contracts aside, you're only verifying that you gave something. There's no verification that you were able to get something in return. So it's technically not a transaction. But anyway, let's say that I wanted to send you something. Half of that 400 million computers, and I don't know what the real number is, but I'm assuming it's probably larger than that even. Half of that 400 million computers have to agree that that transaction happened. Every single one of them has to get it before you can say it happened. I have never heard of a system in my life that is less peer-to-peer than that. So, yeah, just involving everyone is not the same as involving no one. So let's talk about trust. Trust can be established in a couple of different ways. The blockchain technologies generally establish trust by a principle we call mutual disinterest, meaning that statistically there are enough people in a room that don't give a damn, edit that out, that don't care at all, that we can trust that the bystander, whether they are benevolent or evil, the bystander doesn't have any personal stake in the matter at hand. And so other than just being the joker and wanting to watch the world burn, which we can assume are very few of the bystanders, they are not incentivized to lie or pick sides. So, for example, we could do this. I could pick Aaron over here, and I could say to Aaron, Aaron, I promise that I'm going to give you my shiniest penny. And out of all the people in this room, in order for me to convince a judge or a jury that that is not true, I have to somehow incentivize everybody in this room to lie. And that is very, very unlikely because most of you don't care about me enough to lie about me one way or the other, or even care about Aaron that much to lie about him one way or the other. If you were asked what happened, you'd most likely just tell the truth. So this is the principle of mutual disinterest. You just don't care. When there are only 3 people in a room, then it's very easy to convince the one person to care one way or the other, or to incentivize them. But the more people you have, the more difficult it is to get them to care. So that's mutual disinterest, and that's the trust principle of the blockchain for the most part. You're saying because there's 400 million nodes on this network, and most of them don't care and have no relationship with me, if I said that I did this transaction and I published it and they made copies of it, we don't have reason to believe statistically that I could somehow incentivize or overpower those 400 million nodes into lying about what I did. Mutual interest, on the other hand, is a much, much simpler principle. Mutual interest is that I have something that I want, and you have something that you want, and oftentimes there's a third or fourth party that have something that they want. And what we do is we align our mutual interests such that we are in a stalemate to lie. So I tell Aaron I'm going to give him $20 for his phone because it's worth $20. And he's really excited about that $20, so he is interested. He's an interested party, so he's going to give me the phone because he wants the $20. And I'm going to give him the $20 because I want the phone, and there might be an additional party that's a witness because maybe I want the phone and I want the $20, so I'm going to run up and grab it. So we might have this transaction in front of a mutual witness, and the witness would be the one that we would pay $1 each, so that the witness is incentivized equally to tell the truth. So this is what we call an escrow. And in some ways, that's what the 400 million nodes on a blockchain network represent, is kind of an escrow. But that's mutual interest. So it's very efficient, very, very cost efficient, time efficient, and all other ways efficient. And then technically we have systems like OAuth and public key infrastructure, and blockchains do use public key infrastructure. But OAuth is like Facebook. Facebook holds all the tokens and generates tokens and validates tokens, but it will indiscriminately give tokens with the other person's permission. So OAuth is an instance of mutual interest between 3 parties. And then public key infrastructure is just cryptography, where I have a public name that I publish, and I have a private secret that I keep to myself, and I can use the private secret to do a math function on some data that can then be publicly verified. So that's public key infrastructure. And this, I think, it's very, very good. One thing that I love about the hype of the blockchain is that there are now so many more libraries to work with ECDSA keys, which are a very efficient type of PKI key. There are some security concerns about them, but no one's been able to verify whether or not it's relevant. Basically, the NSA said we don't recommend using ECDSA keys, and we don't know if that's because the NSA was able to prove that they can't crack it, or if it's because they were able to prove that theoretically they can. So, but Google came out with an 8-qubit quantum computer, so watch out. Any day now, our cryptography is going to go down the crap hole. So in real life, yes, they are. 6 times 7. So in real life, you have things like notaries or UV IR dyes that represent this. So dyes that you can put in a piece of paper and you shine a light on it, and it actually, the chemical causes the light to shift wavelength. That's kind of cool technology. And your driver's license is something that validates ID, but it has a third party that is the one that stamps it. And driver's licenses are kind of decentralized in a way because every state has their own, and yet there's a political protocol by which any state is able to validate any other state's driving license so that you can go to some other state and still buy liquor. Except some states actually don't allow certain driver's license. I was in Vermont for a while, and I did work at a grocery store, and I do remember we had to tell somebody they couldn't buy beer because the state they were from didn't have the security measures like in the dyes or whatever that Vermont required in order for you to buy liquor in Vermont, regardless of what state you were from. But yeah. And so speaking of trust, price manipulation is a fun thing that happens in the Bitcoin world. So there's a very interesting phenomenon that no one's been able to explain, and a particular audit firm has fired their client over, which is that every time Bitcoin dips in price, the company that owns Tether mysteriously finds an investor that invests in exact increments of $100 million until the price of Bitcoin goes all the way back up to what it was before a few weeks earlier. Very interesting. And you can Google this. Like basically this is fairly well known, but people just ignore it because they're like, oh, but it's the blockchain. The blockchain will serve us. Okay. Privacy. So here's something that a lot of people don't realize, because in the computer world we throw around terms like privacy, anonymity, security, but they're actually not related in the way you think they are if you look them up in the dictionary. So privacy is a function of ownership. For example, private property. I own this property, and we know that I own this property because I have a validated identity that's tied in public record to this property. So that's really important to note. There's no such thing as privacy if there's not identity. Because if two people walk up to each other with bags over their heads and have a conversation because they're anonymous, there's actually no privacy in that conversation because neither party is aware of the other party's identity, so there's no confirmation that they were speaking with the entity that they wanted to speak to, or that that entity is incentivized to not go tell other entities whatever it was they were told. So the whole idea of privacy is completely dependent upon identity. So there's no such thing as anonymity and privacy coming together and happening at the same time because they are mutually exclusive. So privacy is, again, it's about ownership. It's about exclusivity. When I'm having a private conversation, it's not about we're being anonymous. It's that I can take you aside and we can go to a private area that's private airspace where we privately own a conversation together, and no one else is sharing that conversation. That conversation is our private property. And so you see this in technologies like DRM. DRM is a very specific form of encryption that makes it so that you can rent a book potentially for the rest of your life, but you cannot own it. It is not yours. You can rent a movie, whether it's for 3 days or until the Apple license with that publisher expires, which may be 30 years from now, but you can never own that movie. The publishing company retains ownership. It is private to them. And then encrypted is the same thing I was talking about before with the conversation piece. It's a way that two computers or devices can establish a channel. The channel is private to them, and the data that goes over to that channel is owned by them exclusively. And then in the more physical world, I already mentioned land. We also have locks. You put a lock on something to help keep that private to you, to help it keep it owned by you. So this begs the question, how private is a public ledger? There is nothing private about the blockchain. The entire thing is published. Every time you spend a single cent on a blockchain, it is recorded and published. And this is why the FBI really likes people using Bitcoin, particularly for drugs, because Bitcoin is very, very easy to trace. Some of the other ones do a lot more of this like mixing stuff where they basically you say, I've got these tokens that amount to this amount of money, and I want to send them out, and I want to get back about the same amount of money in completely different tokens, and it'll take like a couple of days. They call it mixing. And so they'll basically just trade your tokens at random with anyone else that's willing to trade tokens at random at the lowest price you can trade tokens for. And then after like 10 exchanges, you get tokens back. And so it does become like really difficult to trace that back to you because of the nature of it doing like the money going in so many different places and then ending up back in different accounts. But it does peg you as a target if your IP address is doing that. Because, yeah, yes, it is money laundering. All right. So, hopefully, everything you thought you knew about the blockchain, you now know is a lie. Yes, just like the cake. All right. So, but here's an honest challenge, and then I'll go into some technical details about blockchain. So here's an honest challenge. Can you find any use for a blockchain, and this is the key, that is faster, cheaper, or more secure? Because granted, like I can transfer money to another country in Bitcoin. It's just that the fees are higher than Western Union, you know? I can use a smart contract in Ethereum, but I could just sign something with a public key and then publish that I signed it with the other party that needs it and have them do the same, or, you know, lots of other ways to do this that aren't quite so complicated. So anything that is faster, cheaper, or more secure along any metric in comparison to any existing technology. So if any of you know of something like that, I've searched high and low, and I've yet to find someone that can answer this question for me. Sometimes they start talking about like government voting, and I'll be like, okay, government voting, sounds cool. All right, so everybody gets a private key, everybody votes. Well, you may not know this, but a private key is any number between 0 and essentially infinity. Not quite that high, but 256 bits of entropy is pretty close to infinity as far as humans can reason. So any number in this space is a valid number in the key space. So I can create basically as many identities for just myself as there are people on the planet, and you know, you wouldn't be any the wiser. So I say, okay, well, with this problem of, you know, anybody can create a duplicate identity because all they have to do is roll the dice and get another pseudonymous identifier. And they'll tell me, well, I mean, that's implementation specific. Duh. Right, well, but a possible way would be to have the government run a copy of the blockchain and issue identities and and then I'm like wondering, like, okay, so do you hear yourself saying about how you're like all anti-government, let's get rich, but now you're saying that in order to solve any of the problems that you actually want to solve, we need to get the government involved and we're not going to get rich? So anyway. So, but does anybody have a thought on that?
Blockchain is an existing technology.
Is it any use for a blockchain that is faster, cheaper, or more secure, or anything along any metric than an existing technology?
I was going to say for issuing credit. Some issuing credit in lower third world parts of the for issuing credit, you need land or you need something to base it off of.
Yeah.
That's just how it works.
You need a security.
Yeah.
You need a secured loan.
Yep.
So
for having everybody have access to finding those loans. So not the actual loan, but not capital, what's the word I'm looking for? Not credit, history.
a security.
I can't think of the word right now, I'm sorry. Something to put on the loan, against the loan.
Yeah, collateral.
Collateral, thank you.
Collateral.
Which is the security.
Yeah, okay.
So
Documentation of collateral.
this is something that I can't quite argue that against that point, but I will say that it is circular logic. So the U.S. dollar is fictitious in the sense that the Treasury makes up what it's worth, but it's backed by the GDP of the nation. So considering all the value that we create, gross domestic product, the only thing that the blockchain currencies are backed by is ashes of coal. It's how much electricity was burned. So it's like if I were to stand in this room and pull out $10,000 in $20 bills and I was to burn it in front of everyone and have each of you sign to say I burned $10,000, and then me going up to a bank and saying I used to have $10,000 but I burned it, here's my collateral. However, in today's society, a lot of people accept that in terms of Bitcoin. They're like, oh, someone spent $20,000 on an electricity bill to mine some Bitcoin, and you have proof that someone spent that money, therefore I'll use that. So, from the political perspective that people believe that burnt money is worth something, to them it is worth something. But from the perspective of there's nothing that you actually can break it down to, like $1 you can break down to bread. I don't know. Bitcoin and that sort of thing, But I will say this, if there's anybody else wants to come up with something. Okay, I will say this. I do believe in the potential for digital currencies. I think that it is a goal we should be striving for, and I'm glad that this whole Bitcoin bonanza is happening, because it means that people are realizing that they have some problems that they want solved. They're realizing, at least from a moral perspective, that they like the idea of decentralization, they like the idea of distribution. They have no idea that the technology that they're praying to doesn't do that at all, but they're at least becoming aware that there are some potential benefits there. And so I think that that's good. And this is just kind of like to bookend this with maybe there's a happy story at the end of it all, is I think that when you look at the way people are using these tokens, what could be really cool is if somebody created a decentralized distributed protocol that was like email, but it was a coin protocol. And the way that it would work would be just like you could have, Gmail emails are Gmail branded. It's aj@gmail.com. And Yahoo emails are Yahoo branded. You'd have basically these branded gift card coins, so to speak, where it's like, I, AJ, certify that I am willing to exchange someone maybe hours of my actual work in JavaScript, or maybe I'm willing to exchange storage on a computer that I own. But the thing is, it can't be like these storage coins where it's like, why am I going to trade someone a storage coin for a storage coin? If I have storage, I don't need to buy storage from you. If I have storage, I might need to buy compute from you. Or if I have compute, I might need to buy storage from you. Or if I have compute and storage, I might need to buy connectivity from you. But if, it doesn't really make sense to exchange a storage coin for a storage coin. I guess backups in alternate locations. But the idea being, I think there could be a world in which we basically have barter tokens and service tokens that are branded by someone, like I brand my own perhaps, or I join Upwork.com and I brand it somehow, and this digital token would represent, you can exchange this to someone else, and it guarantees them, it basically is a barter system, but one layer out. So I have storage, I need bananas, I will pay you storage for bananas. You don't need storage, but you need compute, so you'll pay storage for compute. And then I get bananas, you get compute, and they get storage, even though I don't have a relationship with whoever they are. When my token comes back to me and I see this is an AJ token, I myself signed this token, I don't really care that I didn't give it to that person. I just cared that I gave it to someone for bananas, and now somebody's requesting it from me for storage or compute or whatever. So that's the hopeful happy ending I hope to see come out of all of this.
So with that, you're saying basically not decentralized, but we'd be our own currency system?
Well, it would be.
Treasury, for example.
It would be decentralized, but it would need to be something on a protocol layer like email.
Yeah.
And like to you, an AJ coin for storage might mean nothing. But to this person over here, an AJ coin for storage might mean something. So there'd still have to be some level of trust, just like you could open up a bank in your backyard, but I wouldn't feel comfortable putting my money in there because I have no reputation with you. So even though the protocol might work, I may not have trust in the system. I think the same thing would be true. Like if I'm well known for having storage in this group, my storage coins could be worth something in this space where people have reputation with me. But if you were to send my storage coin to someone in California as payment, they might be like, I don't take AJ storage coin because I can't validate AJ storage coin and I don't have reputation with AJ.
So this is how money develops in the first place, is you start don't want apples.
Yeah.
But you want my bananas. Can you offer me something else? And he said, well, I can give you this piece of paper, and that piece of paper will let you go talk to Julia, and Julia will give you something for that piece of paper.
Yeah.
So that anything that serves as that intermediary is money.
Yeah. Yeah, and I think there could be a solution that arises out of all these things that we're learning and all of this, bunch of stuff, but I don't think it's going to solve. Like Walmart has a blockchain tracking pigs right now. I think it's just a PR stunt. But the thing is, the blockchain exists in the digital world and pigs exist in the physical world, and it doesn't matter how many QR codes you put on a pig. If the pig runs out of the gate, you can't scan that QR code to say the pig ran away. I mean, like, the pig ran away. So there's going to be something between digital and physical world. Anyway, any questions about? I can explain blockchain stuff if you want to know nitty-gritty details or technical details. I can answer some of those questions too, because I have worked in blockchain stuff, and the more I've worked in it, the more I've become convinced that it's just a Rubik's cube for investors.
Are there any company here that's doing this, using this?
That's like this type of thing?
Blockchain?
Oh, there's tons of companies in Utah that are doing blockchain stuff. There's tons of them.
So there are jobs.
Yeah, there's definitely jobs in it. Like I do work in it, but I'm just saying that like there's a lot of hype around it because people believe that a solution will be found. And so people are like trying to do things. I mean, I wouldn't want to work for one of those companies long term because unless I saw that they had a direction that was heading towards something I feel like is a real solution. Like I do some work for the Dash community, and they're a fork of Bitcoin, and I don't necessarily believe in the blockchain itself, but I think that what they're trying to do with making digital currencies more user-friendly, I think that is a worthy goal, and I think that if we can solve that problem, we can go backwards and then solve like actually creating an efficient token exchange system. So,
Curious what your thoughts on Zcoin are, and the whole premise of their like Z-proofs or whatever, where they don't have to know any proofs, zero knowledge, knowledge proofs.
So is that one of the ones that only has a white paper and isn't actually real yet, or is it real? Okay, I think I've read on their website, but
yeah. So their whole premise is that they have this algorithm that you can do between two parties that neither party needs to know that each other exists. So the zero truths need to actually be exchanged, and they can still exchange. I don't know. It sounds like a lot of magic in their podcast. Sounds really weird. You guys should look it up. It's like,
well, to me,
it's cool.
It still sounds like a Rubik's Cube thing. Like a crossword puzzle is fun to solve. A Rubik's Cube is fun to solve, but it's not productive. Like, in what situation in the real world do you want to not have trust with someone that you're getting or giving with?
So yeah, so like it takes away their premise is it takes away any security problems like the FBI tracking you through Bitcoin, so that everything is obscured, everything is randomized.
Okay.
So in that sense, there's no trust involved there, but yeah, you do have to kind of trust the system.
So in order for this to work, so what you're saying is this would be like a face-to-face meeting. So this is not, this Zcoin, what it sounds like is you're saying probably wouldn't be a solution for like, I want to pay someone on eBay, but it would be a solution like, if I don't care if I ever see your face, all I want to know is you got 10 grams and I got 10 Zs, and we just swap, but we do it in person so that I know when I send my Zs, I get my grams.
Yeah, I mean, any transaction you do, I guess you have to have some sort of trust that the person is going to send those grams or that eBay is legitimate. So.
Well, yeah, but what I'm saying is if the system itself says there doesn't need to be trust, to me that says it's a broken system that doesn't work for commerce.
Yeah, I think this is the one that's they're trying to solve with the issue of privacy and making sure that the FBI can't track it, nothing can ever be tracked.
But that's not a problem I have. Is that a problem anybody else in this room has?
It's just that the miners, the verifiers, are not they don't have to be aware of the quantities to show that the money is there for the transaction to happen. And they don't have to, they're covered against many of the information that makes the transaction actually make sense. In Bitcoin, they do have no inputs of the amount, the addresses, and that's something that Ctrack wants to shield against. And again, it ends up being budget overhead for this really fancy encryption that just adds computation like crazy, and that might not be a problem that I have.
So that's the thing is like, so they're solving they're solving, to me it sounds like a Rubik's Cube or a crossword puzzle type problem where it's like, it's fun to solve, it's like, it's mentally stimulating, it's very interesting, but it's not something that I'd use to buy pizza. But yes?
I know that, for example, I have a question, right? IBM is testing this blockchain. FDA is also trying to adopt that. And I know that some big accounting firm is testing this blockchain.
Every single firm that can find a way to get publicity out of it is testing the blockchain in some form.
Is, do you feel that there will be a type of industry or a type of software that will be totally replaced by blockchain technology?
Well, what problem does it solve?
I don't know.
That's the thing, is like, I don't think anybody knows. But I do want to go back to your question. The traditional way the blockchain works is you have the whole miner system where people are guessing numbers, and then once a number is guessed, it like is signed and then goes around, and like winner wins, and it propagates, and enough people have, say, yeah, this happened. So what happens is every 10 minutes, the complexity is set so that with the number of computers in the world doing the problems, every 10 minutes a block is solved. When a block is solved, it has some information about like what the magic number was that it found, and then how much the award is for solving the block. And then the block gets filled. The block has a certain size. I think it's 512K on Bitcoin, and it's different on other networks. And each transaction takes up a certain size depending on how many inputs and how many outputs. So inputs is like, in Bitcoin, each value is its own coin. So you have like a 37-cent coin, a 38-cent coin, a $5 million coin. Like there's not discrete values, they're all arbitrary. So you could take in 5 input coins and then put it to 2 output coins. So your blocks are of different sizes, and the cost of the transaction is based on the block size. But anyway, these blocks get full, or they don't. In the early days, or with like new forks that aren't used as much yet, the blocks don't get full. And some of the blockchains, when the blocks start to get full and not enough transactions can get through, and transaction fees get too high, like the problem with Bitcoin right now, they'll bump their block size up. So it'll go from 512 to 1 meg or 2 meg or 4 meg or whatever, and so the block size actually gets bigger to accommodate transaction sizes. And then so what happens is everybody publishes, I want to do this thing, and then if their fee is great enough, whoever solves the math problem, their request, they put the maximum number of requests, starting with the highest value requests, into that 512 kilobyte binary block, and then they push that block out to the network, it gets verified, and then the next block comes on top. So when everybody gets it, it's considered confirmed, and then the next block that lands on top of it, when the next block goes out, that's considered a second confirmation. When the third block goes out, that's a third confirmation. So every single participating party gets a copy of every request that goes out, and sometimes the requests expire like after an hour or after 3 days or whatever. So if I were to go on Bitcoin and say, I want to do a transaction with no transaction fee, sometime within the next 20,000 years, maybe my transaction would go through. If I say I want to do a transaction and I want to give a $100 transaction fee, it'll probably go through in that block. And if I say I want to give like a median level transaction fee, like $3 or $4, it probably won't get in the next block because somebody else is probably going to say I'm willing to pay $10 or $15 before it goes through. But in the block after that, it might go through. So it's just kind of based on how the greater value and the timing. And they just stack on top of each other. And the way they stack on top of each other is basically a part of the block, a part of the math problem that's being solved becomes part of the answer to the next block. And so they build on each other in this way with their signature. So you can't just go solve any random math problem and then if it happens to match, then like put it on top. You have to solve the math problem in conjunction with the previous block. So this keeps it linear and slow and big and huge and expensive.
Which is stringent coverage.
Yes. Yes. It's kind of like like the phone companies give you a 12 megapixel camera and the camera gets bigger every time the SD card gets bigger. Or like Apple couldn't figure out how to get their megapixels any bigger, so now the default is when you take a picture, it's actually a 3-second video, so that it can always take up the space that's there. And that's kind of like what the blockchain tries to do. It's like it always wants to take up as much computing power as available. It's very efficient in finding a way that you never have excess. Otherwise, you could become profitable. All right, that's my rant. Hopefully that was of some value. If not, hopefully it was of entertainment.
I have one final point about privacy coins, and it is that we might be living right now in a very trusting country. It's very, I think it, I enjoy a lot of trust, intrinsic trust, but there are some other countries that have dictatorships that won't hesitate in asking the internet service provider to trace down activity that they don't like. And yeah, there are it's a big world out there. And there are very, very evil people apparently. So that's a case for maybe privacy.
Well, so I'm all for privacy. I just don't see how blockchain solves privacy in a more efficient or more secure way than existing solutions. I think that the idea of like what you're saying, what he was saying with Zcash, that could be a cool concept, but it could be done without a blockchain. It could be just done like Tor basically is that concept. But Tor, again, often becomes the network that criminals use more than a network that honest citizens use, and so it gets blocked by everything and slowed down and throttled and